that we start the paper. All right. The very first question that we have, and students, if I do become inaudible at any point, do let me know. So the very first question, the three states of matter are solid, liquid, and gases, something that we have learned for a very long time. Question 1a. Complete table 1.1 to describe the structures of solids, liquids, and gases in terms of particle separation, particle arrangement, and particle motion. So we just have to fill up this table, and here's the thing. It's asking for the state of matter, solid, liquid, gases. Now some information is already filled up for us. For example, for particle separation, for solids, it said that the particles are touching. And then for particle arrangement, it wasn't there. For particle motion, not there. But for gases, particle arrangement and particle motion are given as random and random. So now we have to fill up for solid. In solids, I will now draw the structure for you. We know that in solids, the particles are arranged in a regular form. They are arranged in layers like this, right? And the particles are fixed about their positions. We know that the solid particles cannot move freely, unlike liquids and gases. That is why for the solids particle arrangement, we write down regular arrangement, because we can see that they are arranged in regular layers. And for particle motion, we write down that they vibrate. The particles ever so slightly vibrate about their fixed positions, but they cannot move in their structure. And then we talk about liquids. For liquids as well, the particles are a bit further apart, but nonetheless the particles are still within touching distance of each other. It's just that it's slightly further away compared to solids. So even though we can't really see a distinction in the particle separation, when we write about motion, then we will write about the differences. So in liquids, the particle arrangement is random, because we see that now there is no fixed arrangement of the particles. So we write down random. And the particle motion, the liquid particles flow on top of each other, or you can write this slide on top of each other, and there is no trend in how they slide and where they will slide. So again, we write for particle motion that it is random. Are you with me, students, till now? Is it clear? Does anyone have any questions? You can raise your hand if you do so. If not, just every now and then give a thumbs up so that I know that you're understanding. All right, thank you, Nisha. Thank you, Yon. Thank you, Arya. All right, it's good to see more students. Okay, and then for gases, we know that in gases, let's see, Samuel, will I be correct if I say they arrange? Yes, you will be correct if you write down they're arranged in a regular lattice. Since this is a table where they're writing in one word, if you just write regular, they gave you the mark over here. And for gases, the particles are far apart from each other. There is no attraction between them. So we just write down apart or far apart. If you write either of them, you're good to go. And with that, we complete the first table, and that's 3 marks for us. And then we move on to B. B is very easy, I would say. Substances can change physically, name each physical change. So they just ask you to state the name of solid to liquid, which we know should be melting, because we have studied science in junior levels as well. From gas to liquid should be condensation. And from solid to aqueous, this one might be new for some of us. We say that that one is dissolving, or you can even write dissolution. I would personally write dissolving. It's more easier that way. And does anyone have any questions regarding the questions till now? If you can successfully answer these questions, you get 6 marks out of the 80 in total. If not, just give a thumbs up and we move to the next part. Thank you very much. It's good to see you guys are there. The next part, it's asking about diffusion. Describe in terms of particles why gases diffuse. Now, the main reason for that is the fact that the particles are randomly moving. Can anyone tell me the definition of diffusion? I know that's not asked over here, but bonus points if you can answer. Does anyone know the definition of diffusion? You're welcome to just unmute and answer, or you can just write it in the chat box.
I think it is particles move from a place of high concentration to low concentration until they're evenly spread
Exactly.
out.
Yes, that is the perfect definition, Samuel. And I can see someone has also written that in the chat box. Yes, you are also correct. So, yes, bonus points for you guys, though the points aren't actually being counted anywhere. But yes, since we are saying that here the particles are moving from lower concentration to higher concentration, the fact that the gas particles are always in constant motion, it helps the gas particles diffuse. So over here you just write the particles are randomly moving. It's important you write randomly moving. And then the next part, state what determines the relative rate of diffusion of gases at constant temperature. If you have attended my paper 2 session, then you will have definitely seen this as well. This was relative molecular mass. And what's the analogy behind this? Think of it in this way. It is difficult for you to run when you carry heavy bags, because if you have a lot of mass, it will be difficult for you to move. And if it's difficult for you to move, it's difficult for you to diffuse. So that is why the relative molecular mass is one of the factors that affect the rate of diffusion. The other one is temperature, but in this question they told it's constant. So that is why we are not allowed to write that down. Does anyone have any questions till now regarding diffusion? If not, a thumbs up and we move to the next part. Thank you very much. And do let me know if I'm going too fast at any point. I will stop and I will let you take time. I will let you have time to take notes. Alright, and the next question, it's about oxides of nitrogen. Gaseous oxides of nitrogen are atmospheric pollutants. One adverse effect of oxides of nitrogen is the formation of acid rain. So this one is already given to us. What they asked for is state two other adverse effects of oxides of nitrogen. Now what is this essentially? This is from the chemistry of environment chapter. The ones that have finished the syllabus, they should have covered this chapter as well, chemistry of environment. In there you will learn about nitrogen and sulfur, or harmful effects of nitrogen and sulfur containing compounds. These two are points that you will have just memorize from your notes. There isn't any elaboration that you should know from here. So the first one that you should write is photochemical smog, which is due to pan. Now this part is something that you will learn in your AS levels. So at the moment I just wrote it down in case anyone's curious, but you don't really need to know what PAN is. The second one being respiratory problems, and the main ones being asthma and lung irritation. You should write respiratory problems. Do not directly write asthma or lung irritation. All right. So these are 2 points that you should just memorize. These are like easy marks that you will get if you just go through the notes for this chapter. In that case, we move on to something else. Part E. In a catalytic converter, oxides of nitrogen are removed by the reaction with toxic gaseous product of incomplete combustion of hydrocarbon fuels. Two non-toxic gases are formed in this reaction. Name the toxic gaseous product of the incomplete combustion of hydrocarbon fuels. Whenever there is incomplete combustion, we will always see carbon monoxide, especially when they're talking about a toxic gaseous product. Carbon monoxide is toxic, carbon dioxide is less toxic. Can anyone tell me what's the harmful effect carbon monoxide causes?
Uh, it bonds to, instead of, doesn't it bond to like red blood cells, which
Exactly.
prevents oxygen?
You are correct.
Yeah.
It bonds with the hemoglobin in the red blood cells, and it reduces the oxygen carrying capacity of your red blood cells. That is why it's a harmful or a toxic gaseous product. So that's the answer for that one. And then name the two non-toxic gases formed in the catalytic converter. So I have written down the two equations that you should know for the catalytic converter. One of them is nitrogen monoxide reacting with carbon monoxide to give you nitrogen and carbon dioxide. The other one is nitrogen dioxide reacting with carbon monoxide to give you nitrogen and carbon dioxide. So in both cases we see that the non-toxic gases being produced are nitrogen and carbon dioxide. So over here you should write down carbon dioxide and nitrogen dioxide. Now some of you might write down CO2 and N2. If you write this down, can anyone tell me how much will you score? This was a 2-mark question. If you write CO2 and N2, will you get 2 marks? Exactly, Samuel. You are correct. You will get 0 if you do this. Now, why is this the case? Because it said name. The name means you write it down in words. You do not write the chemical formula. If they asked you to state the formula, then you will state the formula. If they ask you to name, then you name it. If they ask you to, let's say, identify 2 non-toxic gases, then you have the liberty to choose between the name or the formula. Both are fine in that case. But when it's name, always name, and the same applies for the other one as well. If you had written CO over here, 0. And that is how a lot of students end up losing marks. They write the correct answer, but they write it in the wrong format. That is why they end up losing very crucial marks, because these are marks that you should be scoring in the exam. And with that, we end the first 13 marks of the paper. If anyone wants me to go through any of the previous questions, do let me know. If not, a thumbs up means we move to the next one. Alright, thank you everyone. Okay. So we move on to question number 2. And what is question number 2 about? It's going to be about extraction of metals. Iron is extracted from iron ore in a blast furnace. The iron compound in the main ore used in the blast furnace is iron 3 oxide. State the name of the main iron ore used in the blast furnace. If you have attended the paper 2 session, I think we also did an MCQ or a multiple choice question that was asking about ore of iron and ore of aluminum. So over from there, or from your notes, you can just directly write down that the ore of iron is called hematite. And the formula, if they ask you the formula, then you write Fe2O3, iron 3 oxide. And just as a quick note, the ore for aluminum is called bauxite, and it is essentially Al2O3. And then let's move to the next part. State how the main source of heat is provided in the blast furnace. Over there, what we do is we burn coke. Now you might write down coke, but essentially what we are doing is we are burning carbon. Because you know how we burn coal to run engines at time, or we burn coal to supply energy? The same idea is used over here. The burning of carbon is a combustion reaction, and combustion reactions are exothermic, which means they release a lot of energy. Now yes, in the blast furnace there are other reactions that are also somewhat exothermic, but they're not exothermic enough to heat up the blast furnace to the required temperature. So over here for number 2, the answer is burning coke. Moving on to number 3, name the gaseous reducing agent in the blast furnace, which is carbon monoxide. So notice in this paper, carbon monoxide is the answer twice. And again, they ask you to name. If you write CO, you don't get the mark. And what happens is the carbon monoxide, we are going to see in the next question, write a symbol equation for the reduction of iron 3 oxide by the gaseous reducing agent in A3. So you will write Fe2O3 plus 3CO, giving you 2Fe and 3CO2. And what is going to happen is the iron 3 oxide is going to be reduced, so it's going to lose its oxygen. Are you guys familiar with the phrase oil rig? Oxidation is the loss of electrons, reduction is the gain of electrons. I think all of you have heard this before.
Yeah.
Yeah. All right. So the same thing is happening over here. Iron loses oxygen, so it's reduced. The carbon monoxide ends up gaining oxygen and turns into carbon dioxide. So that is why it's oxidized. And there is another way of expressing oxidation and reduction. It's using oxidation numbers. So the iron, it went from Fe3 plus, gained 3 electrons to form Fe atom. The oxidation number went from plus 3 to 0. Since the oxidation number decreased, that is another way of saying the iron got reduced. Is that clear for all of you? Does anyone have any questions regarding this? All right, thank you very much for responding. Can you repeat which formula you're asking for, Arjun? Oh, it's this one, Fe2O3. Can you not see my screen, Arjun? Fe23 is the formula of the ore, and it's also same over here. Alright, moving on to the next part. And what do we have over here? The main impurity in iron ore is silicon 4 oxide. Write two symbol equations to show the role of limestone in removing silicon 4 oxide from iron ore. So the first thing that you should do is write down what limestone is. And limestone, as you can see over here, is calcium carbonate. And then you will try to analyze what is going to happen over here. If you have gone through the chapter yourself, or if you have finished the syllabus already, you should know that the first thing that's going to happen is the limestone is going to thermally decompose. And what happens when it thermally decomposes is it ends up forming calcium oxide and carbon dioxide. And the calcium oxide is the part that's important, because calcium oxide is a metal oxide, and all metal oxides are bases. So this base is now going to react with silicon oxide. But why is that the case? It's because silicon oxide contains silicon, which is a metalloid or a non-metal, and because of this it's an acidic oxide. So now what do we have? We have an alkaline oxide or a basic oxide and an acidic oxide. So what happens is the base and acid end up reacting. Yes, lime and limestone are the same thing. So calcium oxide, but it's not the lime that you eat, by the way. That one is a fruit. But yeah, so calcium oxide and silicon oxide, the base and the acid, they react to give you a salt. The calcium silicate that's produced at the end, which is also called slag, is basically a salt. And this is a product of the neutralization reaction. Why are we calling it neutralization? Because a base and an acid reacted to form a salt. Are the steps clear for all of you? Does
Yes,
anyone
sir.
have? Alright, at any point if you do have any questions, do let me know. Alright, and then we have this table. Table 2.1 shows 4 different isotopes of iron, A, B, C, and D. Explain why A, B, C, and D are isotopes of iron. So over here you just write down the definition of isotopes itself. You just write down that they all have the same number of protons but different number of neutrons. How do we know they have different numbers of neutrons? Because the nucleon number changes for each of them. It goes from 54 to 56 to 57 to 58, but all of them have 26 protons and electrons. For isotopes, they not only have same number of protons but also electrons, but generally for the definition, as long as we write down the same number of protons, it is good enough. All right. Oh, all right. Here's the thing. In your syllabus, you should have learned about different types of oxides. There's acidic oxides, there's basic oxides, there's neutral oxides, and then there's amphoteric oxides. Generally, the rule is if it's a metallic oxide, we say it's a basic, and if it's a non-metal oxide or formed from a metalloid, in this case of silicon oxide, we say that it's acidic. Now the reason why this is behaving as an acid despite not having H2 is because of the reaction that it undergoes. In chemistry, the way we decide whether something is acidic or whether something is basic is not just simply related to whether it donates H plus or doesn't donate H plus. Sometimes it's also based on how it ends up reacting with substances. So over here, due to the fact that SiO2 will react with your base, calcium oxide, that is why it's called as acidic oxide. But obviously, yes, there are explanations for all of these as well, but it is beyond the scope of your IGCSE syllabus, so I'm not going too in depth in that case. And then the next question asked you to write down the number of protons, neutrons, and electrons for two different ions, both of them of +2 charge, but their neutron number is going to be different because one of them is 54, the other one is 58. The thing is, how will you find the neutron number? The neutron number equals to nucleon number minus proton number. Yes, it would be fine to say the nuclear number is different, but Aaron, I would much rather prefer if you write down the number of neutrons is different. Because here's the thing, the nuclear number is like a summation of the proton and neutron number. So when you say nuclear number is different, it could technically also imply that the proton number is different. Now, yes, that is a very weird, that is not really the most ideal way of answering your question, but when you say the different number of neutrons is different, that is a more definitive answer compared to saying different number of nucleons. That's fine. I don't mind that you ask
Okay, thank you,
questions.
sir.
You're welcome, Aaron. It's good that you're asking questions. So, the neutron number is essentially the nucleon number, or also often called the mass number, minus the number of protons. So the protons for an ion will stay the same. Even if it's a positively charged ion, the number of protons never changes. And ion formation depends on uh, the number of electrons present, whether it has lost electrons or whether it has gained electrons. All right. So the number of protons will be 26 for both of them, and neutrons is going to be 28 and 32. How will you calculate it? You will just do 54 minus 26. You will get 28. You will do 58 minus 26. You will get 32. The good thing is you're allowed to use a calculator for your IGCSE chemistry exams, so you need not worry if you are not that good in maths. And for the number of electrons, you will now have to rely on the charges. So for protons, uh, we know that it's 26. So when we say that the ion has a charge of +2, that means it has lost 2 electrons. So what will we do? We will subtract 2 from the number of protons, and that is the number of electrons. We have 2 more protons than electrons, that is why we have the positive charge. And likewise, when it's +3, that means we have lost 3e minus. So we are going to subtract 3 from the number of protons to get to the number of electrons, which is 23. Is this table clear for all of you? Does anyone have any questions? If not, just give a thumbs up. All right, I see most of you. All right, and then something that you should know is describe the test for aqueous Fe2 plus ions. This thing you will find in your syllabus. Near to the very end of your syllabus, you will find a list of all the ion tests, the flame tests, the test for different gases that you're required to know. Now, if I were to just quickly take a detour and show that. So not only do you have the periodic table at the end of your syllabus, you also have these tables provided. So sometimes you might be wondering that where am I supposed to learn the ion charts and stuff? It's just in your syllabus. You can Google it and you can find it out. All right, moving back to the question. So what did the question ask over here? Yes, I have seen that in the recent papers they are providing the chart for ATP papers as well. So in some way you don't have to memorize it, but I mean, here's the thing, for paper 4 you're not getting the chart, so you do have to memorize it at one point, so why not just do it from the very beginning. All right, so the test that they're asking for is the test for Fe2 plus ions, and this is something that you will just directly write from the table. There is no explanation, there is no in-depth detail that you must know from here. So the test is just straightforward: add aqueous NaOH, as you can already see written, and you can also write add aqueous NH3. That would also be fine, but I chose to write aqueous NaOH. It's fine if you write NH3 as well. And for the observations, again, this is something that you would just directly write from the table, and you would write down that it forms a green precipitate which is insoluble in excess. Now, you don't need to write a full statement that a green precipitate is formed that's insoluble in excess. If you just write green precipitate, insoluble in excess, you get the 2 marks. And just a side note that I would like to add is this green precipitate, if you leave it in the open for too long, it will turn brown. And the reason for that happening is because the Fe2 plus ions get oxidized and turn into Fe3 plus ions. And Fe3 plus, or compounds of Fe3 plus, have the brown color. That is why the color turns brown if you leave it for long. If anyone is doing the practicals, if you ever test for Fe3 plus Fe2 plus ions, you will see that if and near to the end of your practicals, it will have turned brown. All right. A thumbs up would be appreciated, and we move to the next part. Alright, and now they ask you to define the term oxidizing agent. So this is one of the required definitions that you must know. And what is an oxidizing agent? It's a substance that oxidizes another substance but gets reduced itself. Or you can also write that it's a substance that causes another substance to lose electrons and gains electrons itself. That would be also fine over here. That makes, or you can also write removes, to be honest. Removes a minus from another substance and gains the minus itself. So there's two ways of defining oxidizing agent. Either one is fine. So the next part that we are now going to read through is explain why the conversion of Fe2 plus ions to Fe3 plus ions is described as oxidation. We have already discussed this a bit. Essentially what's happening is Fe2 plus loses an electron to form Fe3 plus. That's why the charge goes from your +2 to +3. Since it lost an electron, it lost a negative charge, so it becomes more positive. And since oxidation is the loss of electrons, that is why it's described as oxidation. And then they ask you the oxidizing agent for the conversion of Fe2 plus ions to Fe3 plus ions is aqueous potassium manganate 7. State one condition needed for the oxidation to take place. Over here, the condition is the KMnO4, basically aqueous potassium manganate, must be acidified. Why is it required? You don't really have to know, but I have just written down in case anyone's interested. There's two reasons. One of them is it forms a stable product. Again, you don't even have to know the product itself, but basically one of them would have been O2 minus if it wasn't acidified. But since it's acidified, the product formed is water, which we know is a very stable substance. And the other one is to prevent an insoluble precipitate, basically to prevent the formation of MnO2. But again, these aren't required. If you want the extra knowledge, you are welcome to take it. But for the general students, you can just remember that it must be acidified. And then we have this iodide ions I minus reduce Fe3 plus ions to Fe2 plus ions in aqueous solution, suggests the identity of the other product formed in this reaction. So I have written down the reaction for us so that we can discuss what's happening. So we know that the Fe3 plus ion got reduced. Now for it to be reduced, something must have been oxidized. Something must have lost electrons. So now what was reducing the Fe3 plus ions? It was the the iodide ions. So when the iodide ions end up losing electrons, it turns into iodine molecule. So since they already talked about iodide, they talked about Fe3 plus, they talked about Fe2 plus, the other product that we are dealing with over here is essentially just I2. And notice over here they said suggests the identity. So over here now you have the liberty to write either the name or the formula. Over here if anyone writes down iodine, you will still score the mark. You don't need to worry over here. But if they said state the formula of the other product, then you must write down iodine. Is this clear for all students? A thumbs up. Alright, if at any point you do feel like I'm going a bit too fast, then do let me know. Mainly because I've written down the answers already, so I'm just discussing the points from there. So this one was a 19-mark question, and just in case if anyone's wondering, there are 6 questions in total. So I'm not exactly sure what was the time I announced for this session. Let me just quickly check. Okay, I announced that it will be till 7:30, so we do have time. Let's see if we can finish within that time. So the next question, question number 3, is going to be about stoichiometry. It's going to be about moles calculations, and this is one of my more favorite chapters. I don't know what you think, but I like this chapter a lot, mainly because it's related to math and I like math. So let's look at number 3. A student prepares a sample of insoluble barium sulfate. Student adds aqueous sodium sulfate to aqueous barium chloride. The student carries out the following steps. Dissolve 0.1 mole of solid BaCl2 in 100 cm cube of distilled water in a beaker to form BaCl2. Add an aqueous solution which contains 0.1 mole of Na2SO4 to the beaker containing BaCl2 from step 1. Stir the mixture and then filter it. Dry the solid left in the filter paper. So that's what they have given us for the steps. And then what do they ask? Complete the symbol equation for the reaction, include state symbols. So what's the reaction taking place over here? It's BaCl2 and Na2SO4, and one of the products is barium sulfate. So what's left over here? We have sodium, we have chlorine. So what's a compound containing sodium and chlorine? Sodium chloride, and that's what we write down. And we had 2 sodium over here, so to balance it out, we write a 2 in front. You explain has to be, oh, all right, just a second. But before we do go back to this, let's just finish this equation and then we can go. So the barium sulfate has to be solid because they did mention that it's a precipitate that's formed. And even if you don't know, then your syllabus has a list of solubilities that you should know. Oh, the NaCl is going to be aqueous mainly because it's performed in distilled water, or like the entire experiment is done using solutions. So if you're reacting solutions, you will end up with solutions if it's a soluble salt. If it was an insoluble salt, then you would have gotten a solid. Does that answer your question?
Yes, sir. Thank you.
All right, you're welcome. And the equation is as follows. The reaction that's taking place over here essentially is just a displacement reaction. The more reactive metal displaces the less reactive metal from its substance. And if you just go back to this part, since Samuel had a question asking why it's required to be acidified, there's 2 things, Samuel. What does it mean to be acidified? It means it has H plus ions. Now, if the H plus ions weren't there, what you would end up getting is an O2 minus at the end. And an O2 minus is a very reactive substance. It would react with all the other stuff, or it would interfere with your products. But when water is produced, we know that water is much more stable compared to O2 minus. It isn't as reactive. So that makes it more stable. And that is something that we want so that we have the right products at the end of the day. And another one was the fact that it's to prevent an insoluble precipitate. Since the manganate is reacting, there is always the chance of an MnO2 precipitate forming. And again, that would interfere with my products, or it would interfere with the results of my experiment. So to prevent these 2 issues, we acidify it. But again, this is not required for your IGCSE syllabus, nor for your AS, nor for your A levels if you ever plan on sitting for A levels. So this is just something that you can know as part of your trivia knowledge. Does that answer your question, Samuel? All right, thank you. Okay, the next thing that we have is calculate the mass of solid barium chloride dissolved in step 1. So what do we have? We have the moles of barium chloride, and we want to find the mass. So we have to think of the formula that deals with moles and mass. So moles is equals to mass over mR. So we have the moles, we have the mR, or we can calculate the mR if we do not have it, and then we can calculate the mass. And that is exactly what we will do. So the formula, if you just rearrange it first, mass is equals to moles times mR. So that is what we are doing over here. The moles was 0.1, and the mR for barium, the mass number is 137. Since we have 2 chlorine over here, it's 2 times 35.5. And if you just multiply all of it using your calculator, you will get 20.8. And this is in grams, in case you're wondering. So the mass of BaCl2 that is used in step 1 is 20.8 grams. Is that clear, students? Thumbs up if you understood. And if you want to take notes, do take notes. I would appreciate if you take notes. Alright, thank you very much. Let's move on to question C. Concentration of Na2SO4 in step 2 is 1.25 mole per dm cube. Calculate the volume in cm cube of 1.25 mole per dm cube Na2SO4 added in step 2, which contains 0.1 mole of Na2SO4. So this is again going to use another moles formula, which is moles is equals to concentration times the volume. So we have the concentration as 1.25. We have the moles given to us as 0.10. So to find the volume, what do we do? 0.1 by 1.25. But students, notice something. The unit over here is centimeter cube, but notice the unit of the concentration, it's in dm cube. So when you do this 0.1 over 1.25, you get your answer in dm cube, which you do not want. You want the answer in cm cube. So how do you convert from cm cube to dm cube? All you have to do is just multiply by 1,000. So if you multiply 1,000, at the end of the day, you will get 80, and this is the volume in cm cube of Na2SO4. Essentially, all you're doing over here is just recalling the formula moles is equals concentration times volume, and then finding the volume from there. Is that clear, students? All right, thank you very much. And then they ask you to state the color of the solid formed in step 2. Now, what is the solid formed in step 2? We know that it's barium sulfate. And barium sulfate is a group 2 compound. We know that except for transition compounds, the other compounds are generally colorless. So that is why the solid that's formed in step 2 is also just white. If it was a transition compound, then it would probably have some color, which we are not worried about over here. And then let's look at E. The mixture is filtered in step 3. State the general term given to a solid left in the filter paper after filtration. It's just residue. Even if you do not have chemistry, even if you're not a chemistry student, this is something that you should know just based on your English knowledge. So let's move to the next part of this question, and part F. The actual mass of dry BaSO4 collected in step 4 is greater than the expected mass. This is because the student should do an additional step between step 3 and step 4. So just what the student should do in this additional step and explain why the actual mass collected is greater than the expected mass. A while back a student asked, how would we know sodium chloride is aqueous? Why isn't it solid? Now we are going to essentially see when sodium chloride would turn solid. Here's the thing. You filtered it and you're drying the solid. Now the barium sulfate that was produced over here, it's essentially in a solution of NaCl. Okay, and so when you filter it out, at the end of the day, the residue that is produced, think normally. If sand is wet, regardless of how much you try to dry it, it still contains a bit of water droplets, right? The same happens for our barium sulfate. It contains a bit of NaCl. And when you dry this barium sulfate, or when you dry the powder of this barium sulfate, what happens is the few droplets of NaCl that was also attached, they also turn into solid, because I mean you're drying it out, you're removing the water. Now what happens? You expected only purely barium sulfate, but you also end up with a bit of NaCl. So obviously you're going to get a higher mass than you wanted, right? And that is the entire problem over here. It's the fact that the NaCl wasn't washed away properly, or it wasn't washed at all. That is why the mass of BaSO4 is higher. And now how will you answer this? The answer that I expect you guys to write down is, the step that he missed is rinse the residue with distilled water. There is a reason we are using distilled water. Distilled water doesn't contain any impurities. It doesn't contain any ions or anything. The tap water that we use, it does contain a lot of ions, a lot of metal ions, a bit of chlorine, and a lot of other substances as well. So if you do use it, then it ends up affecting your results. But distilled water contains none of it. It's pure H2O. So you rinse the residue with distilled water, and then the mass of residue was higher due to the mass of NaCl solid. If you write these two sentences, you scored the full 2 marks in this question. Does anyone have any questions over here? Did you understand it properly? If it's clear, a thumbs up is appreciated. Thank you very much. Alright, in that case, let's move to the next one. State the name of this method of salt preparation. Here's the thing. At the end of the day, what did we do? We mixed 2 solutions. Both of them were aqueous. And at the end, we ended up with a solid. and an aqueous solution. This solid is basically the precipitate. So whenever we are doing salt formation by this method, it's called precipitation. And then the next part, state the name of a different barium salt that can be used in place of BaCl2. Here's the thing, BaCl2 was aqueous, it was a solution, and for a precipitation reaction you need another soluble salt of barium, and the most easiest answer that you could use over here is barium nitrate, because all nitrates are soluble. So that's the first one. And then the sulfate salt that can be used in place of Na2SO4. So in place of Na2SO4, a sulfate salt that you could use, wait, I wrote carbonate over here, that you should write down is Li2SO4. It's just that you're replacing the sodium with lithium. It's doing the same thing. Nothing is really changing. And finally, at the end, barium salt that can be made by this method. Now, here's the thing. They asked for a different barium salt. If you end up writing barium sulfate over here, you lose the mark, because they were very clear about the fact that you're using a different salt. So the different salt that you could produce is barium carbonate. And another thing, you might wonder that how would I get barium carbonate if I mix barium nitrate with lithium sulfate? The three compounds that we have over here, they're not necessarily related. They just wanted you to write down different alternatives of the stated compound. Is it clear how we deduced each of them from barium nitrate to barium carbonate? All right, thank you very much, students. Aaron, did you have any question? I saw that you unmuted.
Oh, no, sir, sorry. No.
All right, it's fine. Okay, we are at question number 4, and if I look at the time, we have 30 minutes remaining, or unless I go over time. Let's see. So in question 4, what do we have? Nitric acid, HNO3, sulfuric acid, H2SO4 are strong acids. Now, what is a strong acid? That dissociates completely. It's also written down there, but we'll see. Ethanoic acid, CH3COH, is a weak acid. 1 mole of each acid is added separately to 1000 cm cube of distilled water to form a dilute solution. All 3 acids dissociate in distilled water. State the formula of the common cation produced within each of the 3 acids dissociate in water. All acids release H+. Acids are literally defined as proton donors. So the first thing that you should write down over here is H+. And notice this said state the formula. So if anyone ends up writing hydrogen ion, then you don't get the mark over here. You have to be very clear over here. You have to very clearly write down H+. And then the next one, explain in terms of dissociation why nitric acid is described as a strong acid. This is again a definition that you need to know. Strong acids dissociate completely, weak acids dissociate partially. The dissociation reaction for strong acids, if we were to write down for HNO3 for example, it's going to produce H plus and NO3 minus. But for the weak acid, the ethanoic acid, notice that it's forming an equilibrium. And that's the main distinction between strong acids and weak acids. Strong acids dissociate in a complete reaction. The weak acids dissociate in an equilibrium reaction that ends up leading to less H+. And if you have less H+, it's a weaker acid. If you have more H+, it's a stronger acid. So those are the 2 answers that we write over here. And then part 3, state which of the 3 dilute acids will have the highest pH. Now, having a high pH means means being more alkaline, or it means being a weaker acid. So obviously we are going to choose the weak acid, which was ethanoic acid. It will have the highest pH over here. And then number 4, state the color of thymolphthalein in all 3 dilute acids. The color for thymolphthalein goes from colorless to blue, and it's colorless in acid and it's blue in alkalis. And this is important for you guys to remember. In your syllabus there are 3 main indicators that you have to really No. Methyl orange, thymolphthalein as already stated, and the other one is phenolphthalein. And you also have universal indicator, in case you're wondering, but the universal indicator is basically the colors of the rainbow. So you have to know the color changes of these. So since they asked us to say the color of thymolphthalein, it's just colorless. This is something that you have to memorize from your notes. And then the next part, give the formula of the anion formed when sulfuric acid dissociates in water. So sulfuric acid is H2SO4. When it dissociates, it's going to release its H plus, and you're going to be left with the sulfate ion, SO4 2-. And for ethanoic acid, we already saw over here, it formed CH3COO- an ethanoate ion. And they asked for the formula, so you wrote down the formula over here. If they asked for the name, you would write sulfate ion, and this one you would write ethanoate ion. This is if they asked for the name, which they did not. They asked for the formulas. Does anyone have any questions till now? I'm going a bit fast for this question.
So where's that dash put after the O? The oxygen for ethanoic acid?
Oh, this one. This is actually
Yeah.
a minus sign. It's to
Oh.
show that since it lost an H plus, it's now negatively charged.
Oh, okay.
Okay. And then what do we have? Name the two gaseous products formed during the electrolysis of dilute sulfuric acid using inert electrodes. So I've written down the two half equations that we have. So this is the cathode equation, and this is the anode equation. So 2H plus 2E minus forms hydrogen, and the anode equation 4OH minus turns into O2 plus 2H2O plus 4E minus. The cathode equation, in case anyone's wondering, is reduction. The anode equation, in case anyone's wondering, is oxidation. And yes, it lost H plus because acids are proton donors. You are correct. All right. Name the two gaseous products. So we can see that one of the products is hydrogen, the other one is oxygen. And again, they asked you to name it. So be careful, students. Hydrogen and oxygen are the answers over here. And then number 7, name the salt formed when the calcium reacts with ethanoic acid. They ask you to name it. You can directly write calcium ethanoate. How will you know? Because the ion is called ethanoate ion. So to name it, you write calcium ethanoate. But let's say you want to write down the formula of it as well. How would you do that? You write down the equation, calcium ethanoic acid, giving you calcium ethanoic. Now here's the thing. Ethanoate ion has a charge of -1, but the calcium ion has a charge of +2. So the compound or the salt that formed has to have a zero charge, or has to have a neutral charge. So how will you balance the 2 plus charge of your calcium ion? You will need 2 ethanoate ions, so that you have 2 times -1, and then overall it turns into 0. That's how you form the formulas for different salts. Your goal is to always balance out the charge. The goal is to always have a zero charge overall. And here's the thing, it's an acid and a metal reacting, so whenever acids and metals react, hydrogen is produced as another byproduct. So that is what we write down over here. So the formula for calcium ethanoate is essentially this one: calcium bracket CH3CO bracket close 2. If you don't give the bracket, you don't get the mark. The bracket essentially means that you have 2 ethanoate ions over here. Is it clear for students on how to form the formula of the salt? All right, thank you very much. And then we move to part B. What does part B say? Aluminum nitrate is made when dilute nitric acid reacts with aluminum hydroxide, AlOH3. AlOH3 acts as a base in this reaction. Define the term base. All you have to do is just write down proton acceptor. Acids are proton donors, bases are proton acceptors. As straightforward. And then they say AlOH3 is not an alkali. State what this tells you about the solubility of AlOH3. Now here's the thing. I'm pretty sure all of you have heard of the fact that all alkalis are bases, but not all bases are alkalis. Why do we say this? The reason we say this is because alkali is when a base is soluble. But there are also bases that are sometimes insoluble in water. For example, aluminum hydroxide in this case. So what does this tell us about the solubility? Since it's not an alkali, it's insoluble in water. Does everyone understand this? Thumbs up if you do. All right, thank you very much. And then name one other compound which forms aluminum nitrate when added to dilute nitric acid. Essentially, you're looking for another oxide of aluminum that's going to react with your acid. So what we write down is aluminum oxide. Now, is aluminum oxide acidic, basic, or is it both? Can anyone tell
I think
me?
it's amphoteric.
Exactly, you are correct. It's amphoteric. And can anyone name any other amphoteric oxides? Aluminum oxide is an amphoteric oxide. Have you learned any other amphoteric oxides as part of your syllabus? Right. In case you haven't, the two that I will tell you now are zinc oxide, ZNO, and PbO. Zinc and lead oxides are also amphoteric oxides, if I'm not wrong. Do correct me if I am. All right. Moving on to number 4, the oxidation number of O atoms in Al. Oh, for amphoteric oxide, what you just write is it's an oxide that reacts with both an acid and a base. If you write that, that should suffice. Reacts with both acid and a base. All right. So they gave us the oxidation number of O atoms as -2, and we are asked to write down the formula of the formula of aluminum ion is given as Al3+. They gave us the charges, very easy for us. Determine the oxidation number of N atoms in AlNO3. So the rule is for any compound, the overall oxidation number is 0. So all the different oxidation numbers, if we add them up accordingly, we should end up with 0 if it's a compound. If it's an ion, then the oxidation number is essentially the charge of the ion itself. So for example, for aluminum, the charge is going to be +3. So that's why we write a +3 over here. This is for the aluminum. And then inside, we have 3 of nitrate. So 3, and then we start a bracket. We are trying to find the oxidation number of nitrogen. So we represent that using an X. And the oxygen, they already told us, is -2, and we have 3 oxygen over here. So 3 bracket -2. For minus signs, I always tell my students that use brackets, because otherwise you end up making mistakes. Like if you don't use the bracket, you end up doing something like 3 - 2, and then you get a very wrong answer. So brackets are very important. And then it's a bit of math and algebra to get to your answer. So 3 minus, so first I'll multiply the 3 with the x. I'm getting 3x, and then 3 times -2 is -6. 3 times -6 is -18. So I write that down over here. 3 minus 18 is -15. If I take the -15 to the right hand side, that's a +15. Essentially, I did not write that over here, but what we do is -15 plus 3x is equal 0. 3x is equals 15, and finally we write down x is equals +5. And it's very important you give the plus sign, because oxidation number can be positive and negative. So it's important you make the distinction whether it's positive or negative. Since we got a positive value over here, we write down +5. Is the calculation clear for all students? Thank you very much. I appreciate that you guys do ask questions every now and then. Hey, students do not. Alright, and now we are at organic. The last 2 questions I believe are organic questions, question 5 and question 6. And I think we'll be done within schedule for today's lesson. So let's see. So question 5 is about homologous series, and 3 general characteristics of alkanes are: they're generally unreactive because they do not have a functional group. They show trends in their physical properties such as melting and boiling. They have similar chemical properties. So some characteristics are given to us. What they asked us to do is describe two other general characteristics. Now, if you go through your notes or if you look at the syllabus, there's 5 main points listed over here, and they wrote down 3 already. So you only had 2 other options. In other cases, what they usually do is they maybe state 1 or 2 so that you have multiple options to write down the 2 other characteristics. But for this question, you did not. You had to write these. There is no other option except for these. So the first one that you should write is the consecutive members differ by CH2. Now, what does this mean? For example, methane, CH4. Ethane is C2H6. What is the difference from methane to ethane? It gained 1 carbon and it gained 2 hydrogen. That is why we say that they differ by CH2. And then the general formula of alkanes is CnH2n plus 2. That is something that you can just check from here as well. CnH2n plus 2. If n is equals 2, I get C2, and then H2 times 2 plus 2. 2 times 2 is 4. 4 plus 2 is 6. So that is how the general formula is obtained. The general formula of alkane is something that you should memorize. That is required. So if you want to take a note, these are all the 5 points that you could possibly write to describe characteristics of homologous series. There isn't anything else in your syllabus that you could write down over here. Is that clear for all students?
Yes, sir.
All right, thank you for your answer. Okay, and then we move to part B. State the trend in the boiling points of alkanes as the carbon chain length increases. For any homologous series, as the carbon chain length increases, the boiling point will increase. Why does it increase? It's due to more intermolecular forces. When the intermolecular force increases, you're essentially required to supply more energy to break the bonds. So that is why when the number of carbon increases, electrons increases. And always remember, when electron increases, intermolecular forces increases. That is why the boiling point also ends up increasing. Is this idea clear for all students? More electron, more force, more boiling point. Thank you very much. Okay, point 2. Part 2. Name one other physical property of alkenes that show a trend other than melting points and boiling points. Describe this trend as carbon chain length of alkenes increases. The one I decided to write is viscosity. You could also write about volatility. Viscosity is essentially the thickness of your fluid, or it's basically how much your fluid will flow. You can also sometimes say it's the density to some extent. And what's the description, or what's the change that's going to happen? The viscosity is going to increase as your chain length increases. The more number of carbons you have, the difficult it is for your molecules to flow. Because think of it in this way. Let's say you have methane, CH4. Let's say you have a longer substance with, like, let's say 5 or 6 or 7 or 8 carbons. Which one will flow more easily? Obviously the smaller one. Obviously the smaller one's molecules will arrange more efficiently. They will definitely move past each other more efficiently. But if you look at the longer chain, if you try to do that for this one as well, let's say you have more chains here and there, then it gets more and more difficult for your molecule to flow. And that is what viscosity is all about, the ability of your molecule to flow. Now, if you were to write about volatility, volatility is the ability to vaporize. How volatile a liquid is, or how volatile a substance is, essentially gives us an idea of how much it will vaporize or how easily it can vaporize. And same for volatility. If you were to write volatility over here, you would write down that it decreases. Because remember, we said that the boiling point increases. So for volatility, we would say that it decreases. Are the two ideas clear for all students? Okay, thank you very much. And then this one, a very common error that students make. State why alkenes are described as saturated. For saturated, you must write that it's all carbon-carbon bonds are single bonds. Many students will write that there aren't any double bonds, there aren't any triple bonds. That will not score the mark. it is very, very, very important you write down carbon-carbon bonds are single bonds, because here's the thing. If you write down there are no double bonds, it could very well imply that it still has triple bonds. And if it does have triple bonds, it's still also considered unsaturated. So from now on, whenever they ask you about saturated or unsaturated, always write that all carbon-carbon bonds are single bonds. And if they ask you about unsaturated, write that all carbon-carbon bonds aren't single bonds. Okay. All carbon-carbon bonds aren't single bonds. That's the distinction between saturated and unsaturated. I hope this is clear. Please do not lose marks for this in the exam. Okay, and then question D. Propane has a structural formula CH3CH2CH3. When propane undergoes a mono substitution reaction, mono meaning one, with chlorine at room temperature, two organic products can be formed. State one condition needed for this substitution reaction to take place. And straight away you should write down it's UV light. And why UV light is required? It's because it provides energy to break down the chlorine-chlorine bond. If you don't have enough energy to break down the chlorine bond, you won't have chlorine atoms that could end up reacting with the propane in the first place. So that is why UV light is required over here. Does that make sense for all of you? Are you still with me? All right, thank you very much for responding. So now in part 2, what do they ask? Give the structural formula and state the name of each organic product formed. So over here, not only are they asking for the structural formula, but also the name of the organic product. So here's the thing, what's going to happen is the propane is going to lose a hydrogen. And where it loses its hydrogen from matters, because that way you get the different structures. So now you have two options. Either you can remove from the first one and add a chlorine, or you can remove from the second one and add a chlorine. And how will the structures change essentially? Let me just draw out one. Carbon, 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 H, 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 another H, and another one, another one, another one. This is propane. Now what can happen is one of the hydrogens over here is replaced with chlorine. Okay, and students, do keep in mind, if this chlorine was, let's say, over here or here, it would still be the same molecule. It's not a different molecule. It's still the same molecule if, let's say, the chlorine is over here and the hydrogen is here. A lot of students often think that no, this is now a different molecule. No, that is not the case. And you guys will still make this mistake in AS, but I hope that if you are serious, then you will remember this, because this is a very common mistakes that students make. So this is one structure, and they ask for the structural formula, so we don't need to show the bonds or anything. We just write them down in this form. CH3, CH, Cl, CH3. And notice that this is different from the one that I have drawn over here, because the one that I have drawn is actually the second one that I wrote down in the answer space. And the first one would be something like this. H, H, and the chlorine would attach in the middle. Okay, so now how do we count it properly? So you'll just start from any of the ends, and your goal is to make the number for chlorine the smallest possible number. So 1, 2, 3, and even if you go from the left hand side, it's still 1, 2, 3. So for this one, it doesn't really matter. But let's say if you had another carbon over here, H and H, then if you were to count from, let's say, left to right, it would be 1, 2, 3, 4. But if you count it from right to left, it would be 1, 2, 3, 4, like this. It's important that whenever you have these types of compounds, you always associate the smallest number with the chlorine or the alcohol or whatever group there is. So over here, we will choose the smallest number, which is 2. So that is why when we name it 2-chloropropane. Yes, Samuel, do you have any question? Okay, I see. For B2, could I use that the reactivity decreases as... No, Samuel, over there they asked about physical properties. Now reactivity is a chemical property, so you can't write about that in place of physical property. All right. So the name of product 1, since I drew CH3, CHCl, CH3, I wrote it as 2-chloropropane. 2 because the chlorine is in the second carbon over here. And then for product 2, since they did say that there's going to be 2 products, since this time the chlorine is with the first carbon, I wrote it as 1-chloropropane. Is the way the names written make sense? Are they understandable for all students?
Yes, sir.
Thank you very much. Alright, I see most. Okay. And then you are asked to write another definition. Define the term structural isomer. So what will you write down? Molecules with the same molecular formula but different structural formula. Make sure to get this right. Whenever you have definitions in the exam, please never lose marks in definitions. Definitions is like getting free marks because you essentially know the question beforehand. All you have to do is just recall from your previous knowledge. So let's move on to the very last question, and it's a small one, so we will be done within time, I think. So what do we have over here? Compound E, shown in figure 6.1, is an ester. Draw a circle around all the atoms which make up the ester linkage. So the ester linkage is essentially comprised of the carbon-oxygen double bond and the carbon-oxygen single bond. This is as much as you are required to circle. You need not circle anything more than this. And this is a pretty easy question, I would say. And then the next part, name the compound E. So we know that this is an ester, but to name esters, we need to know a certain format. The format being alkyl alkanoate. Alkyl alkanoate. Now, how do we understand what is alkyl alkanoate? From the structure, what we are essentially looking for is, we know that esters form when an alcohol and a carboxylic acid react. And when they react, they form the ester. So the alkyl part is taken from the alcohol. The alkanoate part is taken from the carboxylic acid. So let's say over here, how will I know which part represents carboxylic acid, which part represents the alcohol? You will look for the carbon-oxygen double bond. Whichever side contains the carbon-oxygen double bond, isolate that. That is your carboxylic acid, or that's the part from your carboxylic acid. So over here, how many carbons do we have over here? 1, 2, 3, 4. So when we have 4 carbon atoms, our carboxylic acid is called butanoic acid. And then the remaining part must be our alcohol in that case. So this part is from your alcohol, or this part is from your alcohol. And we have 2 carbons over here. So this is simply ethanol. So carboxylic acid is butanoic acid. The alcohol over here is ethanol. But this doesn't show me how to do alkyl alkanoate. So now the ethanol is going to be named ethyl alkyl, and the alkanoate is going to be taken from butanoic. So butanoate. So the name of this ester is ethyl butanoate. Is the way we named the ester sensible for all students? If you remember this format, alkyl alkanoate, you will never get an ester name wrong. Alright, thank you very much. And then the next part, deduce the empirical formula of compound E. Empirical formula is one of the easiest things that you could be possibly given. All you have to do is just count the number of carbons and hydrogens. So if we do that, we can see that we have 6 carbon, 12 hydrogen, and 2 oxygen. And the empirical formula is the simplest formula. So we will divide them by the largest possible number to simplify it as much as possible. So if we divide everything by 2 over here, we end up with C3H6O. And that is essentially the empirical formula that we have written. Is it clear how we form the empirical formula? We first find the molecular formula and then just divide by the largest possible number, or basically the common factor, to get the empirical formula. And we are almost at the end. Now here's the thing. We already know that we reacted ethanol and butanoic acid to form our ester. So in D1, the work is already done for us. They asked which 2 compounds react together to produce E. You can just directly write ethanol and butanoic acid. And then the next part, suggest a suitable catalyst for this reaction. This is something that you have to remember. This is also something that you will see in your AS exams, and what you should write down is concentrated H3PO4 acid, or concentrated phosphoric acid. If you write the name, that is also fine, because they did not specify anything over here. And then this part, determine the number of unbranched esters which have the molecular formula C5H10O2. For this one, what I like my students to do is create a table. And here's the thing what you should do. You have 5 carbons over here. Now in an ester, what did we see? The carbons could be for your on the acid side, or they can be on the alcohol side. Depending on which side they are, the molecule changes. So that's what we are going to do. The 5 carbons, we are going to try and split them into an acid column and an alcohol column. So that's what we have over here. First I take 4 with the acids, 1 with alcohol. Then I do the other way around, 1 with acid, 4 with alcohol. Then I do 2 with acids, 3 with alcohol. And lastly, I do it the other way around again, 3 with acids, 2 with alcohol. So essentially each row over here represents a different ester. So I have 1, 2, 3, 4. I have 4 esters in total. Does this trick help? Because if you want to draw the structures, you can, but here's the thing, they did not ask you to draw it, so why bother wasting time and drawing the structure? You can just draw this table quickly and know the answer. And this would especially help you in your MCQs, where you don't need to draw, you just need to know the number. Does this process make sense for all of you?
No, so sorry, could you not how you did it?
Could you repeat, Aaron? Your mic is a bit muffled.
Sorry, could you repeat the method you just used?
Oh, alright. Here's the thing. They gave us the molecular formula of the ester, C5H10O2. So I know that I have 5 carbons over here. It's just that I don't know how they're going to be distributed. And they asked me how many unbranched esters are possible. So let's actually draw one of them. This is a possible ester, and if you were to check the molecular formula, this is C5H10O2. But then I could also draw something like this. CH3. This is also C5H10O2. Now here's the thing. Once I increase the number of carbon by like 1 or 2, the number of structures required increases a lot as well. So you don't really have the time in the exam to draw all of it, because here's the thing, it's just a 1 hour 15-minute exam, so you need to be quick. So for that we are going to use this table. And what is this table? It's just how the number of carbons is distributed among the acid portion and the alcohol portion. So what we start off with, we know that 5 and 0 is not an option. Definitely get that out of the way from the very beginning. So you must have 1 at the very least on each side. So I give 4 to the acid, 1 to the alcohol, and then I can do the other way around. I give 1 to the acid, 4 to the alcohol, and then I can start increasing the number of carbon on one side. So 2 acid, 2 for acid, 3 for alcohol, and lastly 3 for acid, 2 for alcohol. And if you check, there is no other combination that you could distribute the number of carbon atoms. So we say that there are 4 number of unbranched esters that could have the molecular formula C5H10O2. Is the process clear now, Aaron?
Yes, sir. Thank you.
All right. You're welcome. And students, we are at the very end of this paper. A combustion question to close it off. All unbranched esters with the molecular formula combust completely to form carbon dioxide and water only. Even if they do not state that it's carbon dioxide and water, you must know as a student of IGCSE Chemistry that the product of complete combustion is carbon dioxide and water. So the reaction itself isn't an issue. What is an issue is the balancing. So to balance these equations, what I always like to do is you first balance the carbon. So you multiply a 5 with the carbon because you had 5. And then you balance the hydrogen. So you had 10 over here, you have 2. So if you write a 5, it balances out the hydrogen. Now look, how many oxygens do you have? On the right side, you have 5 times 2, that's 10, plus 5, that's 15 oxygen, right? On the left hand side, what do you have? You have 2 and then another 2, that's 4. Consider it like this. You have 2 over here, right? So you need to balance this O2 in such a way that you have 13 oxygen molecules, right? Now here's the thing. If you write 13 like this, then that wouldn't work. But if you write it like this, yes, that is where I'm getting to, Samuel. If you write 13 over 2 like this, if you write 13 over 2, the 13 over 2 times 2 gives us 13, which is what we're looking for. Now, yes, you are allowed to write down fractions, but for IGCSE, I generally suggest you do not. For IGCSE, I would much rather prefer if you write 13 over 2 initially and then multiply the entire equation with 2. So over here, what would we get? We would get 2. The 13 by 2 times 2 gives you 13. 5 times 2 gives you 10. 5 times 2 gives you 10. Now, technically in the mark scheme, they do say fractions are allowed, but in the answer space, they always write whole numbers. When you go to A's, then they start including fractions, but for IGCSE, I've never seen them write fractions. They might accept it, but let's not take the chance. So this is the combustion equation that we have over here. And students, with that, we can conclude this paper. If anyone has any questions from the previous ones, we can go through them. If not, that is it for today's session. If you do have any questions in general, you're open to ask now. Yes, Aaron, ask.
So you're going to be offering more chemistry lessons?
Uh, For the free workshop that we were hosting, this is the only lesson we have left. We did cover the paper 2. We will provide a recording of that lesson, but other than that, we are not providing any free lessons at the moment.
Okay, sir.
And before students you leave class, I have provided a link for feedback. It's basically a Google Forms. Please take your time to fill up the form. It's important you do so because these lessons were conducted free of charge, because mainly I want to see how students perform in general, and I want to share my knowledge with students as well. So it would be highly appreciated if you would just take the time to answer the Google Forms. The link is provided. And yeah, that is about it for today's lesson. If you do not have any other questions, you are open to leave. But again, I can't stress enough, fill up the Google form. It really helps if I see the feedback.